We are actually going to start partway down the page. We'll do the B part last. All right, so we're going to start where it says how C changes the graph. So C is our phase shift. So we're going to start by labeling our X and Y axis again. Nothing has changed yet with the labels. So this is pi over 2, pi, 3 pi over 2, and 2 pi. Do the negatives. Y-axis, I'm going up to 1, down to -1. Okay, so this is a sine graph. So I need to start by plotting just my parent graph of sine dots. So again, like last time, if you have colors, colored pencils, colored pens, anything like that, please get those out. It will make it easier. If you need some, I have a bunch of colored pencils up here. Grab them if you need anything. But if you just have pencil dots everywhere, it's very confusing, okay? So I will always do the parent graph in red. So look at those red dots and let's see if those make sense to you. Everybody have the red dots? Almost. All right, I'm not going to connect those because I need to shift all of them. So where do you think I'm shifting? Like up, down, left, right? Where am I going? Going to the right. Yes, you guys see how this is minus pi over 2 in the parentheses? Means we're going to the right. And we're going to the right by pi over 2. Does that make sense? You see it? Okay. Since I'm going to the right, I always start on the left side of my graph. So this dot on the end, I'm just going to draw an arrow for a couple of them. It shifts right by pi over 2, which is only one tick mark right now. This dot goes right by pi over 2. You don't have to draw arrows for all of these. It's just so you can see what's happening. You guys see the pattern of blue dots here? The last one doesn't really have anywhere to shift to. And then you need to figure out what is happening on the left end of your graph. So guys, following the pattern, what do you think? Over here, is it going to be a 1, 0, or -1? -1, okay? Because it's up, down, up, down. Also, the two ends of your graph are always going to match. So since this end was at -1, I know this end is going to be at -1. Then you'd shift by pi, which is actually 2 tick marks. Yeah. Yep. Okay, and then I can connect. So there's my graph. Questions? If you don't know your parent graphs yet, this is going to be hard, okay? Because it comes from starting with the parent graph every single time. And then I shifted right pi over 2. So do you see the red dots?
Ticking it right by one.
One tick mark, yeah.
If you can go by half.
Half a pie. You guys want to try two? No, not ready yet? Okay, we'll do it together. Start by labeling. Same labels. Okay, guys, so what parent graph am I sketching first? Cosine. Where does cosine start? Like, what happens? Yeah, on the y-axis it's at 1. One that kind of looks like a W. Get those dots down correctly, otherwise everything else is really confusing. So guys, what's the phase shift this time? Okay, so left pi? Yeah. So guys, don't put a plus or a minus with the phase shift. Either write out the word or use an arrow. So we're going to the left by pi. Okay. How far is pi? Like how many tick marks? 2. Yeah, do you see? Yeah, okay. So, since I'm going left, start on the right side, and I have to move 2 tick marks. So this dot goes all the way over here. This dot goes all the way here. There's no actual flipping. I mean, that's what it looks like at the end, but you've actually shifted it to the left. Okay. The graph looks exactly the same as the first one we did. Can you guys fill in the last 2 dots on the right? Like, do you see the pattern? Okay. There's our graph.
We always just say phase shift and then we do it with formula.
What do you mean?
Do they do that with a formula or do they just say phase shift to the right?
Phase shift is always to the right or left, and it just comes
Wait,
from
remember they add pi? Oh, okay.
when there's something like plus or minus with that x in there. We did the ones where it was plus or minus a number outside, and that's the up or down, but in with the x makes it left or right.
This is really like circle. Like it's like now we're like doing it a line.
So if we took values from the circle,
Yeah.
which we took like x and y values from there, the input now became the angle, and the output became either the x or y part of the coordinate. And if you think about how that curves around the circle, that is the curve that's happening in the graph. And some of them are positive and some of them are negative. So that's
Yeah.
it's actually used in a lot of stuff. A ton of stuff with music is related to the way the waves work. I have a video I can show you. We won't do it today because we don't have time, but a guy put a phone in his guitar and recorded the strings as he played them. And you can actually see like the little sine waves going on and how different pitches have different like amplitudes and wavelengths. Yeah, if we get into the applications with it, So, like, I was just doing that in honors today, and like we were doing a Ferris wheel problem. Because like the way a Ferris wheel travels, your height from the ground follows a Chinese wheel. You know, so it's things like that where it's not, it's a repeated pattern. Yeah, you have to be able to identify like the amplitude and the period and all of that. But anything with like sound waves, any sort of like echolocation type stuff, like it all, I mean, this is the very basic beginning of all of that, but it's where it comes from. So it does actually matter. All right, let's try again. Okay, turn the page for me. All right. You're going to do the first one on your own. What do you notice about it? No markings, and it has a -1. So you don't have to fill in this. We haven't talked about this yet. If you want to fill in the others, you can. You need to recognize that you are going left by pi, and you have to go down 1. You can do that all at once, so plot your parent dots, and then go left and down and put a new dot, okay? So I'll give you a little bit of time here. You have to put your own tick marks on there. We haven't talked about period yet, so that's why I crossed it out. We'll get there today. Get those paragraph dots.
I just took my for that time. Yeah. I have 3 doctors. Which was 8 like this
Great. So when you shift left, you know, when you go off the track, we have Did you guys start with those red dots? Yes? Okay. Look up here and check when you're ready. How we're doing. You're very quiet. This is bad. We're good. You don't. You're like, I don't know. I'm dots everywhere. Do you just need more time to look at it first? This one too. Okay, next one's not fine. We have to for a stretch in there as well, so yes, I'll help you. Anybody, any part of number 1 that you're like, yeah, I got the red dots, I don't have any idea how you got the blue dots, like any part of that you need me to walk you through? Yeah? Izzy, was that you? Or you got it?
I got it.
You got it? Okay. Izzy, how you doing? You good? Okay, alright. Anybody? Again, use colors. You can't write small. Erasable pens are helpful here too. Alright, let's, I didn't fill in amplitude. Dice domain, remember, is always going to be negative infinity to infinity for these. And then range on this one would just be -2 to 0. Alright, so let's look at 2. Okay, so we start with labels. I have to do a little more on the y-axis because I'm stretching it and shifting up. X-axis, nothing has changed. Alright, what paragraph are we looking at? 9. And I do the stretch by 3 when I do my paragraph dots. Okay with that? Instead of going up to 1 and down to -1, where am I going to go? What is 1 times 3, guys? 3. Okay. Alright, good start. So sign starts at 0, 0, then again that next point instead of being at 1 would be at 3. So we're just doing that stretch right away. Alright, then where am I shifting? Right by pi, and what about up and down? Up 2. Alright guys, so I just need to take the dots, right pi, up 2. I is 2 spaces, yeah. And then guys, fill in the pattern on the left side. Here's where we are. Kind of missed my dots, but. Haley, was that one better? Okay. Okay.
Is the first one up there? So,
Yeah, I'll spell it for you. You got it? Yeah. Okay. This one, the only thing that's different is we have an
No.
amplitude change.
Don't you just have to figure out the first dot and then you go from there?
As long as you understand your pattern and whether you're going up or down
Yeah.
from that point, yeah.
So like for the first one, you just start from the first one, and then that would be your first one. Or,
Like
you
that's
just
where-
the first one, really just that one, and then
Go from there, yeah. Yeah, when I start, I don't actually count over 2 and down 1 for every single. I like do 1 or 2 of them and I'm like, oh, there's the pattern.
Yeah.
And I just follow that. Our domain is just negative infinity to infinity. Range, it looks like negative 1 to 5. How we doing? Fantastic. Excellent. We're not going to do number 3 right now because I want to give us time to talk about the B value and the period change. Questions on this one? I know some of you are still working. Alright guys, when you're ready then, let's flip back to, oops, this page. Alright, so the B value, that's the only one we haven't talked about yet, that changes the period of the graph. The period of the graph is just how long it takes for the entire graph to occur. It starts repeating itself after a certain point. Okay, so it's like how long until it starts repeating itself. So the way you find that is 2 pi divided by b, and yes, it's technically an absolute value of b. So we'll look at our 2 parent functions here for sine and cosine. The period of both of those is just 2 pi. Okay, because there is no b value with the parent function. We're going to sketch those parent functions again just because we want to be really good at it. Alright, so let's look at the first one here. We have a spot to write the period, period, and then you can cross out this primary interval part. We're not actually filling that in on any of those. Okay, so this one says sine of 2x. So what is the b value? 2. Do you guys see the coefficient on x there? That is b. So to find the period, we do 2 pi divided by b, which is 2 pi over 2. So what does that equal? Pi. The next part, do not write what I'm going to write. Okay, just pay attention to what I'm doing. Do not write this down. If I label the x-axis the way we have been for everything, what the period change means is that now instead of the whole graph happening by the time you got to 2 pi, it would all happen by the time you get to pi. Okay? So for a sine graph, again, don't graph this. You see how that's the whole graph? Like that's what we normally graph. Yeah, it all happens by the time we get to pi. And if I kept going, how many times would it happen by the time I got to 2 pi? Twice. Twice. That's why b is 2. Okay? So if b was a 5, it means it would happen 5 times by the time you got to 2 pi. You're not going to graph it like that. We're going to relabel the x-axis to only look at like one period of it on either side of the y-axis. So, let me erase all this. That's just so you understand where it's all coming from. Okay, so now labeling the x-axis is super important. I'm going to write above each tick mark what our labels were before, but they are not what we're going to go with now. Okay, the period of the graph is now pi, so what do you think the last tick mark is going to be? Pi. How did we figure that out?
It's the period, so it's like, that's the, because if it's going to take 2 times, you know,
Getting
it's
there.
like the period is the normal amount divided by how many times it happens.
Okay, so
Therefore,
divided by which number?
divided by p, which
Yes.
is the number of times that it would happen.
Out to 2 pi. Yes, okay. So we figured that out by dividing by 2, right? Because our b value was 2. What you need to do then is take the other original labels and divide them all by 2. Okay, so what's pi over 2 divided by 2? Pi over 4. This is where I realize if you guys are good at fractions or not, okay? So pi over 2 cut in half is pi over 4, right? Realize pi over 2 divided by 2, that's the same as pi over 2 times 1/2. So what is pi going to become? Pi over 2. What about 3 pi over 2? What will it become? 3 pi over 4. Okay, so there are your labels. And we'll do them on the left. Now, to graph this, you are just going to plot the parent graph dots in their normal spots, like where they would be if we hadn't relabeled anything, if there hadn't been a period change. Just plot them where you've been plotting them the whole time. So for sine, I'd start at 0, 0. The next tick mark is up at 1. The next tick mark is back to 0, down to -1, 0. Doing the same on the other side. And then we can connect them. So just the graph, does it look any different than your parent graph? No, but is it different? Yes. Do you see why you have to label the x-axis now? Okay, because it changes what we're actually graphing. All right, do you guys want to try number 2? Still not ready to fly on our own here. Okay. All right, let's go through it. What is the b value this time? 1/2. So what is 2 pi divided by 1/2? 4 pi. So that means you'd only see half of the graph by the time you get to 2 pi. Okay. All right, so that last tick mark is going to be 4 pi.
That's so easy to do, just 3 pi, 2 pi, 1 pi, 0 pi.
3 pi, 2 pi, 1 pi. Thanksgiving's coming. Okay. With all of these, like if you need a process and you need to divide by the b value every time, go for it. If you're looking at it and you're like, the first one, like, yeah, I get that it's divided into 4 equal parts. They're going to be pi over 4, pi over 2, 3 pi over 4. By all means, if you see it, just label it. That's great. But if you need a process, use the process. Trust the process. Yeah, I don't know. Do you guys trust me yet? Oh, okay.
Real.
All right, guys. So it's sine again. So once you have it labeled, it's just the parent dots. That's it. Okay. Block that. Well, we can put it all together. So we can have where you relabel, and a stretch, and a shift, and a shift.
That's how we did with everything.
So you know the ones we were doing right before this, where it was like amplitude change, you shifted right or left and up or down. So if you relabel first, it's just that afterwards.
Oh,
So
no, I'm saying that this is like what we did last year with parabolas.
oh, okay, where you put it all together then.
Yeah, where you start out with just like one thing and then it ends up with
A lot of
4
things.
things that you put together.
All right, guys. So there's number 2. Doing okay? Labeling is key. All right, try 3 and 4 for me. I will walk around and see how you're doing. Yes, it's stuck. Yeah.
Oh, wait, this is
Because on this one, I don't know.
Wait, what if we just use Where the fraction is from. I know this one's fine. You try it.
Yes, yeah,
So what is it?
divided it by. How do you get on, like,
Divide by 4. Yeah, you divide by 4.
No, but wait,
Yeah.
yes. So,
Oh, so what is
and I'm drawing
Yeah.
that would be the first. Sorry, yeah. Yeah, that is, yeah.
Like it just would look like almost like this. Or whatever. This size.
So you can either go through, like, you know, like that's what they were. You got this by dividing by.
Oh, this is actually a lot easier than I
So, we're gonna take half, just take each of those. So then, yeah, so then, 1/8. And then, oh, so when you're doing it, and that is.
Oh, that's. Oh, that makes more sense.
Yes.
Oh.
Okay. I like this.
So I didn't know
I
how.
like this.
Yeah, me.
So it was,
I haven't used
this turned into this. Wait, 3? So what you need to do is take each one of these and multiply it out. So this is times 4. What is 3 times 2? So that was 3 times 3. What is times
Jackson,
So.
what's the deal with Jordan?
Correct.
It's like, this is applied to all of them, you just kind of, you multiply by a specific context.
Yeah.
And then, so you just multiply. I just need like a formula, and that is good for me to process, right? Is it the same, like, what you're doing, not really changing your, what we multiply by? Yeah, I tried it.
Okay. Alright guys, let me do some labeling. Let's see how we did.
Yeah, so this is like, okay, so like, divided by.
Guys, walking around, somebody asked if you had to label all the tick marks or if it was okay if you just put the ones at the end.
Yeah.
Not going to be getting 4 on these assessments if you're only labeling the ends, okay? How'd I get 3/8? Okay, what did you do to turn 2 pi into pi over 2? Like, how'd you get that last label?
You do 2 pi over 8.
Right. So we did 2 pi divided by 4, right?
Yeah.
That's the same as multiplying by 1/4.
So you do.
Just multiply all the original labels by the reciprocal of e, essentially. So pi over 2 times 1/4, that became pi over 8. Pi times 1/4, pi over 4. 3 pi over 2 times 1/4, that's the 3 pi over 8. Guys, are you getting 3 pi as your period for 4? Yeah, okay. Are we enjoying those fractions? Really what you're doing is multiplying by 3/2. Yep. Because it really ends up being, no, it should be 3 pi over 2, right? Because it's 6 pi over 4? Yes. Anybody want me to walk you through the process of those labels? Or are we getting it? I know it's tedious, but are you like getting the idea? I'll plot the cosine graph. Give me a minute to catch up, and then we'll try to get 1, maybe 2 more in before the end of class, where we put all of it together. Yeah. Right. Okay. You just you always have to have the b value factored out.
Well, I just did it because for pi it's always
Okay. So you got the original label.
Yeah.
Okay. That'll work.
Yeah.
Okay, guys, turn the page for me. Let's look at number 4 down here. We'll leave it like that. That's okay. All right, guys, we're almost done. Stick with me. If you look at number 4, do you guys see how it has everything? Okay, so if you can do this, you can do any of them, right? Can't add more than this to it. So first thing we have to do, we have to rewrite this. Anytime you have a b value that's going to change the period and you have a phase shift, you have to write it factored. Okay? So the coefficient on x, you're going to see it's a 2. I am factoring a 2 out. -1 is still way out here. What would be in the parentheses with the x? X plus what? It was pi, and now I factored out a 2. Yes, it would be pi over 2.
Do you have to change that?
Because your phase shift is not left pi. What is your phase shift? Yes, the phase shift is left pi over 2. Okay? So, anytime that you have a b value and a phase shift, factor.
Do you have to put the arrows in
You either need to write the word up, down, left, right, or use arrows. Don't just say plus or minus, because sometimes you guys write weird things, especially with the phase shift. Okay.
Is 2 the B value?
2 is the b value. Whatever the coefficient on x is, that is the b value. So that guy is b. So what is the period of this graph going to be? Pi. Just pi, yes. Period is pi. So you gotta put your own tick marks. Okay, can amplitude be negative?
Oh, wait. No.
Okay, so this is just 3. Yes, there's a negative that matters, but it's not part of the amplitude. Do you guys know the labels, what they'll be? We've done these before.
Oh, pi.
Good start.
Wait, no. I know pi is all the way at the end, and then is it pi? No, you
Half
know,
a pi and
3
some.
Pi over 2.
Pi over 2 is in the middle.
Yeah, 3 pi over 2. Right?
Yeah.
Guys, think if you had money and you're trying to get to $1, okay? $0.50. Pi over 4 is here. There's a quarter.
Oh, 3 pi over 4.
Oh,
That's what I meant.
good.
That's pretty much what I meant.
Pretty much.
Yeah.
Oh, man.
Math be nice, even though they don't trust you.
Be a whole food.
Okay, for parent dots, I'll do those next, and then I'll pause for a minute to make sure everybody's caught up with me. It's cosine. I'm going to do the -3 when I do them, okay? So it starts down here at -3. 0, +3, 0, -3. Make sure everybody's okay to that point. Once you have the red dots, what is going on with the shifting?
It goes to the left. 1 tick.
Try again.
Is it?
It is to the left. How many ticks though? Because I have to go pi over 2.
So, oh!
This is why we
I was
label.
still thinking it was. That's right.
Yes.
Still.
Now you believe me that you need to label, right? This is another reason why just labeling the endpoint isn't super helpful. Okay, because you got to know how far you're actually traveling. So we have to go left 2 tick marks and down 1. So we got to go all the way over here and then down 1.
No, wait. B is also 2.
B is 2. Yes.
B is the station.
No, C is the phase shift.
The -3 to amplitude.
+3 is.
What's like the,
Yeah, the absolute value is -3.
Yeah.
Yes.
so what's
So
the
A-
negative?
Negative just means you're flipping it. So it matters, but you don't write it when you're writing amplitude. Yes, here.
Or good. That was maybe baby.
flip it.
So cosine normally starts up here.
Yeah.
If I flip it, I'm going to start down here. So instead of looking like that,
You're supposed to start grabbing.
that's where I would start in the y-axis and then follow it out. If I'm shifting, I start on one end or the other end. Okay. All right, guys. We're out of time. Questions on that one? That is as messy as it gets. It's got everything in it. Got a flip, amplitude change, period change, phase shift, vertical shift.
Dude.
And what's hilarious is it looks like nothing happened other than it went down one.
Wait, did you flip it again?
No, I flipped it and then shifted left 2 tick marks.
Ah.
And that makes it look like it didn't flip at all. Okay, homework, guys. Your homework is the page that actually says homework standard 16 at the top. So it's not the first sort of chart looking page. It's the second one that says homework standard 16. There's a front and a back. Graphs are on the back. The column that says primary interval. Don't do it. Scribble it out if you want to. We do not graph bars with a primary interval. Okay? No, I know.
Jersey,